Welcome to Section 10, Lesson 2. Simplifying radicals means rewriting the radical so the radicand contains no factor that is a perfect power matching the radical's index. For square roots, no perfect square factor remains under the radical. For cube roots, no perfect cube factor remains. The procedure has two steps. First, factor the radicand to expose the perfect power factors. Second, take the square root or cube root of each perfect power factor and write it outside the radical. What stays inside is the leftover that did not match. Variables follow the same pattern. For a square root, every pair of identical variables produces one outside the radical. For a cube root, every triple does the same. Anything left after pairing or tripling stays under the radical. Today's two examples cover a numeric square root, a square root with a variable, and a cube root simplification. The procedure scales to any index m by replacing pairs with n tuples. Take the square root of 72. The radicand is 72, not a perfect square, but it has a perfect square factor inside. Find that factor. Factor 72 as 36 times 2. 36 is the largest perfect square factor of 72. The radical splits into the square root of 30, 6 times the square root of 2. Take the square root of each factor. The square root of 36 is 6 exactly. The square root of 2 is irrational and stays under the radical. The result is 6 times the square root of 2, written 6 root 2. The number line below shows where 6 root 2 sits, between 8 and 9. The simplified form makes the value's position obvious. The original square root of 72 does not. Simplify the square root of 50x cubed. Both the number and the variable need attention. Factor the radicand. 50 equals 25 times 2. X cubed equals x squared times x. So the radicand is 20. 5 times 2 times x squared times x. Split the radical. Square root of 20, 5 times square root of x squared times square root of 2x. The first two pieces are perfect squares. The last is what cannot be simplified further. Take the roots. Square root of 25 is 5. Square root of x squared is x, since x is non-negative inside this radical. The simplified form is 5x times the square root of 2x. Example 2. Simplify the cube root of 54. The procedure is the same, but the matching factor is a perfect cube rather than a perfect square. Factor 54. 27 times 2 equals 54. 27 is the largest perfect cube factor. The cube root splits into cube root of 20, 7 times cube root of 2. Take the cube roots. Cube root of 27 is 3 exactly. Cube root of 2 is irrational and stays under the radical. The simplified form is 3 times the cube root of 2. The dot on the cube root curve shows where 54 lands. The height of that dot is 3 cube root of 2, which is approximately 3.79. The simplified form is exact. The decimal is approximate. 3 takeaways for simplifying radicals. They generalize from square roots to any index. Find the largest perfect power factor of the radicand. For a square root, find the largest perfect square. For a cube root, find the largest perfect cube. Higher index radicals follow the same pattern with their own perfect powers. Pull one factor out for each matching power. A square root pulls one factor out for every pair. A cube root pulls one out for every triple. An nth root pulls one out for every n tuple of identical factors. Anything that does not pair up cleanly stays under the radical. The simplified form has a coefficient outside, an irreducible factor inside, and is the canonical answer to any radical simplification problem.